All right, so we're going to make an arcade game, and it's going to be an asteroid shooter game where you're looking at the player's looking from a top-down view, and then you've got a little spaceship that you're going to move back and forth. You can only move on one axis, so you'll move back and forth, and then you'll have asteroids coming down randomly from the top, and you have to avoid them. And then if you get hit by an asteroid, you'll catch on fire. And then if you get hit by a second asteroid, you'll be destroyed. But in between that, there will be health packs that will also come down. And if you grab a health pack while you're on fire, you get your life back again and you get restored. So you get one hit for free, your second hit, and you've got to start over, unless you take a health pack to energize you and get restored. So we've got damage and we've got health that we're going to be using in this as well. A lot of this that I'm going through, you probably won't understand right away. And so just kind of follow along with me. And like I said, we'll just do that. And then because I didn't require you all to purchase the book, what I'll do is I'll scan this and put it out there this week so you can have access to it if we don't finish the whole thing today. So we'll see. So let's go ahead and get started. So make sure you've got your a blank level here, and then what we'll do, a blank level, then we'll just go to File, New Project, or New Level, File, New Level. And let's just choose empty level. Empty level. It's going to be completely dark in there. Empty level. Click on create. And because I'm recording it, I'm going to try and go a little bit faster. And if you miss something along the way, I'll put the recording out there for everybody so you can still get it. So, all right. So anyway, so we went through, we named it, we created it, we added starter content to it. And this level is currently saved as untitled. Let's rename this. So let's save current level as and call it level_0, but don't hit enter yet. Level_0. Let's put it into a new folder. And so in the starter content folder, let's create a folder in here. So I'm going to right click, new folder, and let's just call this maps. And then save your new level_0. Save that in the maps folder there. So, and then we'll just click save. So, all right. It's totally black world. We can't see anything. There's not even any lights in here. Once we get something put in there, then we'll start to add lights to it. So, also, we want, when we open this back up, we want to open it to level 0. So let's go ahead and change that. So go into Edit, Project Settings, and then when your project settings, go into Maps and Modes over here. And then make sure that your editor startup map and the game default map are both set to level 0. Right in there. And then you don't have to save this, it saves automatically. I'm just going to grab my project settings and kind of throw it up top there. In fact, everything that we work on, I'm just going to throw up top here, the tabs, and hopefully I've got enough memory that it'll let me do that without crashing, but we're going to save frequently as well. So, all right, so anyway, we're creating a custom game mode next. Make sure that you go back to the content folder because we're going to be creating different folders through here as well. So let's go through and make a blueprint. We'll be making blueprint classes during this game. Level blueprints only work on a particular level, but blueprint classes will work in multiple levels and in multiple games if you want to migrate them over. So we'll be working in blueprint classes so we can click and drag and make multiples of a single object if we wanted to. So, all right, so let's, we're in the content folder. Let's right click again and create another folder, new folder, and let's call it blueprints. And open up your blueprints folder. And then let's right click in the blueprints folder, and we're going to create a new blueprint class. So right click, go to blueprint class, and we're going to create a game mode base. So you see the options about the fifth one down is the game mode base. And so the game mode base defines the game being played, its rules, scoring, and other facets of the game type. So we're going to choose game mode base. And let's rename this arcade shooter underscore game mode. So arcade shooter underscore game mode. Arcade shooter underscore game mode. And then just file save all. All right, so now that we've created this this game mode here, let's go back into our project settings, and let's go into our maps and mode again, maps and modes button, and let's make sure that our default game mode, currently it says game mode base. Let's choose the one we just made, the arcade shooter game mode. Arcade shooter game mode. Choose that one as your default game mode. All right, the next thing we'll do is we're going to create a custom pawn and a player controller. Okay, a custom pawn and a player controller. So I'm going to go back into my level, and let's go back to the blueprints folder if you're not already there, and we're going to create another blueprint class. So right click, blueprint class. And this one, we're going to pick the, let's see, down here, you see where it says all classes? These are just some common ones, but one we want is not on here, so click on all classes down there and it pops up. And then just type in default pawn. If you don't see it, you can either scroll to it or type in default pawn, and there it is, I see default pawn. So click on default pawn and then click select. All right, let's rename this hero underscore spaceship. Hero underscore spaceship. All right, and now let's create another one. That's our pawn, and now we need, and you can tell it's a pawn. Look at the little icon on it right there. It's got a little, like from the game of chess, it's got a little pawn there. And then if we were to double click this, and when it opens, and then your tab, if I put it up there, you can see it's got a little pawn icon up there as well to let me know that it's the pawn. But now we're going to create a player controller, so let's do that. So once again in our blueprints, we're going to right click, go over into blueprint class, and we want a player controller, and I see the player controller right here. It's the fourth one down. So click player controller and name this one hero underscore PC for player controller. Hero underscore PC. And that will be our player controller. So, all right, so let's open up our hero spaceship, double click it, and put it up to the top there. And then let's make our spaceship here. So, let's see. All right, go back to your. That was weird. Oh, let's go ahead and save it. Just go ahead and save it for now. All right, go back into your level, and then we're going to create another folder. So click on the content folder, and then right-click, new folder, and then call it vehicles. And so open the vehicles folder, and then in here we're going to import, if you remember from our teams, there is a UFO FBX right there. So if you can download that from Teams, I don't think you can drag it from Teams, can you? Can't drag it from Teams. So if you just take it and download it, download the UFO.FBX, remember where you download it from. Let's see, I think I just downloaded mine into my downloads folder. There it is, and then just drag it into that vehicles folder. and then you can say import all. So it's a little bit of a UFO guy right there. It comes over with its own yellow material, and we should be good. So, all right, let's go ahead and save all. You can see down here in the content browser, there's a save all button. So instead of always going up to File, Save All, I can just click Save All here. And then Save Selected, yes. All right, so now let's go into our Hero Spaceship blueprint, which, just like I said, leave it at the top, don't close it, because we'll be going in and out of that quite frequently. And if you'll see in our, there we go. If you don't have, if it didn't open to the viewport page here, then you can click on this. Sometimes a line will come up and it says Open Full Blueprint Editor. Click on that if your viewport didn't come up. Okay. So, all right, over here in the left-hand side, and where it says Components, let's click on the Mesh component. And instead of this sphere, that's right there, let's come over into the right-hand side where it says Static Mesh, and let's go find that UFO. So I'm just going to click on my sphere drop-down and choose the UFO.fbx there. So I may have to scroll through because we downloaded a bunch of starter content. So there it is, UFO. So just click the UFO. That's what we're going to use there. And so now he's kind of small, so if you go over into the scale property, let's change it all to 0.75 for all three axes. So 0.75 on all three axes, and then you can lock that scale axis if you want. And you'll notice that the spaceship is now as big as the collision model there. The red outline is the collision model, which we see the collision component is right up here at the top. So, all right, let's compile it. Clicking the compile button up here in the upper left, and then let's move on. So, all right, so let's go back to our level, back in our blueprints folder. So go inside our blueprints folder and open up the arcade shooter game mode. And then over here on the right under details, let's look for our default pawn class. You'll see there's the classes rollout. And then when you look down, about the sixth one down, default pawn class, let's click that and choose the Hero Spaceship. So mine's right there, Hero Spaceship. So you're over here, you selected the arcade shooter game mode. Over here in details under the classes rollout, go to default pawn class, and then Hero Spaceship is what we want there. So, all right, and then also in the defaults panel, we would like to click on the player controller class. So you see the third one down is the player controller class, and we're going to choose our Hero PC for that. So Hero_PC for that, and then once again click on compile and do a file save all. All right, so the next thing. Now the next thing we're going to do, or coming up to one of the next things, is that when we go to make our pawn move right and left, things have changed in Unreal 5 from what they were in Unreal 4. And when I made this last night, I set it up the way you're supposed to set it up, and I couldn't get my guy to go right and left. Everything else in the game worked, but I couldn't get my guy to go right and left. So either we'll figure it out today, or I'll spend some time tomorrow and the next day figuring it out how to get that particular thing working. But they've changed it. It's different, and I'm not sure. Maybe I'm just missing one thing on it. But we'll at least get it set up and take a look at it working. So, all right. So what we'd like to do next is we want to disable the default movement here. So let's go open up your Hero Spaceship if it's not open already. Open up your Hero Spaceship, and then in the class defaults panel, over here on the right hand side up here at the top, your class defaults. If you click class defaults there, then your details will go to class defaults. And then we want to make sure that add default movement bindings is unchecked. So down here under the pawn rollout, where it says add default movement bindings, we need to uncheck that because it says if true, adds default input bindings for movement and camera look. We want to disable that. So uncheck that so it'll make it false. And then once again, we will compile and save. Compile, save all. All right, so we disabled the default movement of our spaceship here, of our hero spaceship. All right, now we're gonna set up the movement for it, and we'll just see how it goes. So go back into project settings, and in the input, if you scroll down, you'll see there's an input category here. And this is the way we used to do it, but if you come down here to the input, in yellow it says the access and action mappings are now deprecated. Please use the enhanced input actions and input mapping context instead. And so we used to create these action mappings here, meaning we would map keyboard presses to some action. So you could set up a keyboard press to make your character move right, left, jump, up, down, back, forth, whatever, and other things as well. But this is the thing that's different now. These are deprecated here. You can still set them up to work, but it does say to ask you to use the enhanced input actions. So instead of going to input, if you look up just a little bit, a few spaces up, it says enhanced input. So we'll go to the enhanced input one and play around with this. So anyway, now I've got to remember where I was when I did all this. So we may have to come back to this. So, you know what, let's come back to this so we don't spend time here. But anyway, I just want you to know that the trigger default values here are down, pressed, released, hold and release, tap and pulse. And each one of these has their own different thing that they do here. So we'll come back to these. Maybe after we take our break, we'll come back to those. So, but anyway, so let me skip by this one, mark my page there, and we'll come back to that. And, all right, so anyway, so let's go back to our level. And the next thing is that we want to set up our fixed camera position, or our fixed position camera. So let's go into our blueprints folder and open up our arcade shooter game mode if it's not already open. And in the editor, we should show our class. It's showing us our class defaults panel. That's correct. And then we want to, and if you don't see it again, then click on the Open Full Blueprint Editor. Sometimes that shows up and sometimes it doesn't, and I'm not sure why. But anyway, that's how you get back to this point here. So let's go into our event graph. And in our event graph, let's look for the event begin play node. And you can see there's our event begin play node. And you can pull that over a little bit away from the tick there. And let's drag off of the executable for the event begin play and type in spawn actor from class. You don't have to put any spaces in there. From spawn actor from class, and eventually, even if you don't finish typing the whole thing, it just shows up there and you can press enter when you see it's been highlighted in blue. So spawn actor from class, and the class is currently undetermined. So anyway, let's go ahead and click down on the select class, and we're going to choose the camera actor. So you can scroll down to it, or you can search for it. But camera actor is the class we're going to spawn here, and then we're going to click drag off the spawn transform property here, the little orange one. And if you click off of that, type in a make transform node. Make transform. And then just put that over to the side there. The return value should be hooked up to the spawn transform. And then let's go ahead and set the camera above the player. So we're going to do that, the transform node under location. Just make it on the z-axis 1000. The x and y should stay at 0. And then the rotation property, make the y-axis -90. We're going to rotate it, so instead of looking straight ahead, it's going to rotate -90, so it's looking straight down, okay? -90 straight down. And then to the right, over here, the spawn camera actor, over here to the right of it, let me see if I can scooch my details over a little bit so you guys can see. Let's just right-click and type in Get Player Controller. Get Player Controller. All right. And then the return value, let's drag off of that. I'm going to put that underneath over here, the Get Player Controller. And then drag off of the return value of the Get Player Controller and set a, type in Set View Target with Blend. Set View Target with Blend. If you just type in Set View, it shows up. Set View Target with Blend. And then we're going to hook the spawn actor camera node return value here. We're going to set that into the Set View Target with Blend node View Target. So this return value here will be on the new view target right there. So you see they're going to cross. So the target is the player controller. The new view target is the spawn actor one. So we're going to set the view target with the blend there. So, and then hook the spawn actor camera's executable to the set view target with blend executable right in there. And that looks done. So, all right, so it should look like this. Then begin play to spawn camera actor. Coming off the spawn transform is the make transform. And then coming off the executable is a set view target with blend. And then a get player controller down here with return value hooked up to the target, and the return value here hooked up to new view target. So, all right, let's click compile. Let's save, file save all. And let's go into our level. And we haven't really dragged our Hero Spaceship into the level yet, so let's drag Hero Spaceship into the level. And let's go ahead and hit play. And I don't see him, so not in mine anyway. So I'm gonna do that, and what's happening is probably my spaceship, when I placed it in there, is not set near my guy. So I selected him, and if you'll remember, our camera was set at 001000, and look at my little Hero Spaceship is set to 370 -10. So I'm going to set the location, the X and Y, to 0 and 0, and let's set it all to 0. Set it all to 0. So 000 is where my player controller is going to be. I mean my hero. What is he? My Hero Spaceship is going to be. Then hit play again. And why do I not see it? Oh, it may be because it's dark. We may not have any light in there yet. So let's go ahead and add a light. So I'm going to click on the add box up here. And then let's go to lights. And I'm just going to put a directional light in there. A directional light. All right, and normally you want to see the directional light. I want the light to be looking like it's pointing down, or at least in a downward fashion. And here's my directional light, and it is pointing down, kind of at a 45-degree angle, which gives my spaceship a little bit of shadow in there, which is fine. So I'm going to go with that for now. So I've put the light in there, the directional light. Now when I hit play, there we go. Now I can see my spaceship. And why are there two of them? Oh, we spawned one, didn't we? So we don't even need to put one in there. I'm gonna close it. And my hero spaceship that I dragged into there, I'm gonna delete that. I don't think I need that. I don't need to drag it in there. So now when I hit play, hero spaceship is in there, but I can't see him. Why can I not see him? Hero spaceship spawned at 001,000. That's interesting. All right, I'm gonna close this. So I'm gonna drag my camera. Yeah, you can.
Are we spawning the spaceship at the transform instead of the camera? You know, we said we rotated it and move it 1,000 up. We just
Did it?
wanted the ship instead of the camera.
Oh, did we?
Yeah. We can spawn drag now.
I'll just delete it and re-add it back.
The light's fine, I think. Oh, but that's the one you got.
No, we've got the camera. So when the level begins to play, it's going to spawn a camera actor at 001,000, and it sets it there. Oh, are you talking because that says player controller?
I think it's spawning the ship at the transform instead of the camera. So maybe when we get player controller, I don't know if it's changing the view there. I don't know.
All right, well, I'll mark that down. We're going to keep going, but yeah, I'll make a note of that and see. Wonder what happened if I set my camera a little bit higher. So if I set my camera to like 1200, compile it, save, and then hit play. So now I can see it. I just set my camera higher, but this is spawning. When I select it, yeah, it's spawning at 1,000. I don't know where I set that. Gosh. Yeah, if someone knows where, let me know, but I don't know where I set that to spawn it on there. So I just set my camera up a little bit higher, and then it worked fine until I find where I set my spaceship. So, all right, let's keep moving on. Did I do it in my Hero PC? No, I did not. Okay. I'll go back and look. Maybe I missed it or something. All right. So make sure that you save what you're working on. We've got our camera set up. We've got our spaceship set up. And the next thing we're going to do is set up an obstacle-based class. And so go back to our blueprints folder again. And in your blueprints folder, we're going to right-click and create blueprint class. And then the parent class we're going to choose is an actor. So choose the actor, and then rename it obstacle. Obstacle. And then save that. You just click Save All there. All right, so up here, let's double click it and open it. And up here in the components, let's add a new sphere collision component. So we're going to add, and make sure you're not adding just a sphere component. That's not what we want. You have to scroll down. You'll see that they're categorized. If you go down into the collision rollout right there, we want a sphere collision component. So I'll click on that, it brings it into our scene. And then what we want to do, you can just click on that. We'll just use the term sphere there, that's fine. But you see we have a default scene root. This is the default scene root component. It cannot be renamed or deleted. It can be replaced, however, by dragging and dropping another scene component over it. So that's what we're going to do. Let's click on the sphere, drag and drop it on the default scene root, and it makes the sphere the new scene root. Okay? So, all right, so it replaces it. We're going to set the sphere's radius. If we make sure you have the collision sphere selected here, and then come over here on the in the details, and we're going to set the sphere radius to 50. It's currently at 32, so let's just set that to 50. So we'll make it a little bit larger, and then scroll down below to where the collision rollout is. And the collision rollout, make sure that it says overlap all dynamic. Mine says that by default, so make sure it's there. Go on.
My Unreal crashed.
Oh, okay. Well, I am recording this, so you'll be able to work it, but go ahead and open it back up. And have you been saving frequently?
I lost connection.
Okay. Yeah, you can pick up where we leave off, and then you can go back and check it later. So, all right, so back in our components panel over here, we want to add a new sphere static mesh component. So this time when you click add, you can choose the sphere common component right there. And because we do want to add that, I'll just leave it at sphere 1, that's fine, or you can rename it something, whatever you want to rename it. I'll leave mine at sphere 1 there. And then in the details panel over here, now because we already have a collision model on it, we don't want to have the double collision. So over here in the collision rollout, go to where it says block all dynamic, say no collision. We only need to test for one collision, and we already have a collision component on it, so that's what we need. So, all right, another thing we want to do is go into the add again, and let's add a rotating movement component. You should remember this from when we did our windmills, we added a rotating movement component on it. So just keep scrolling down until you see the movement rollout. So we use a rotating movement component on this. And you can just leave it, the name on it is fine. And we'll make changes to that later. So, all right. So we should be in our obstacle. Let's go ahead and compile and file save all. All right, and let's click on the construction script up here and the little tab up there that says construction script. What a construction script does is that when you have a blueprint class, if you want to make objects a little bit different, like we want each of our objects to rotate differently, and maybe we want to scale them a little differently, the asteroids. We don't want them all to look the same when they're coming down. So in a blueprint class, the construction script is where we put in the information that can make each one of these different as they're spawning in our level, okay? So that's what the construction script does, is it allows us to make each of the instances a little bit different. So we don't have to have, if I want, half a dozen different looking asteroids, I don't have to make half a dozen different blueprints. I just make one blueprint and then go into the construction script and make my changes there for how I want it to look differently. So let's take that rotating movement component and let's drag that into our construction script. And there you can see it puts a little reference in there. I'll pull that down. And then let's pull off of the blue output pin there, and let's type in set rotation rate. Set rotation rate. All right, set rotation rate. And then make sure that the executable pin of the construction script goes to the set rotation rate exec pin there. And then underneath this set rotation rate, we're gonna right click and just type in random rotator. Random rotator. And so that way we don't have to, you know, set it up. We'll give it some values that it can rotate randomly for. So we set up random rotator. Let's hook the return value of the random rotator into the rotation rate of the set rotation rate. Right there. And let's see. Now we're going to create a couple variables here. Over here on the lower left-hand side, you'll see there's a variable rollout. And this is where we create variables. And so there's a little plus sign over there. So when we click on the plus sign, we're going to create some variables. The first one is random scale min. So random scale min for the minimum. Now, making our minimum and our maximum, this currently is a Boolean variable. We don't want Boolean variables because Booleans are like 1 or 0, on or off, yes or no, true or false. That's not what we're trying to do here for a random rotation. We want actual numbers in there, okay? So we'll put numbers in a moment, but the thing is that we want to make it a float. We want to make it a float instead of a Boolean. So just click on that word Boolean, and there's all different variable types that come up, and we're going to make ours a float. And a float is just, it's like a number that can be a decimal. So it could be like 36.58. It could be a whole number as well. It could be 23. Or it could be 100.96852. You know, just whatever. The float is a number that can be a decimal. Let's also make another variable called random scale max. Now the cool thing about this is that because we just changed the name of or the type of variable, the next variable we create, it's going to give us whatever the last one was. So it won't keep popping up Boolean. Now it gave us a float there as well. So that's pretty cool. And one thing you'll notice for you programmers, artist designers, you may not know this, but we want to make these variables able for us to change the numbers on them. You'll see that these, the eyeball, all we see is like the eyelid right here and it's closed. And it says the variable is not public and will not be editable on an instance of this blueprint. If you turn it on, then it will make it visible to the player, or I guess it'll make it visible in our details later when we're playing in the game. We don't really need that. I just wanted to mention it right here. But what I do need is that if I want to say what the starting values of each of these are, if we come over here, you'll notice down here where you would normally input it, it says please compile the blueprint. So it won't allow us to enter the starting values until we compile the blueprint. So let's go ahead and compile. And now you'll notice the min and max values over here. It allows us to do that. So for min, let's put 0.7. That'll be a 70%, which is the minimum scaling we want of it when it's rotating. And then the max, let's put that at 1.5, which means the scaling of our asteroid is going to fluctuate between 70% of the size and between 150%, well not size, I'm sorry, rotating. 70% rotation up to 150% rotation. So that's what we're going to do there. Now, let's drag off of the set rotation rate over here, the executable. Drag off of that and place a set actor scale 3D. Set actor scale 3D. All right, set actor scale 3D. And underneath it, just right click and type in a random float in range. Random float in range. There we go. Ah, look, do you see something on there that might, look at these min and max values right there. So, all right, so now what we'll do, there's two ways to do this. I'm gonna show you the easy way. So the easy way is just take the random scale min over here in the variable, click, drag, and just drop it onto that pin, boom, and it automatically does it. The hard way, if you want to take the max, you could drop it over here and say get random scale max, and then hook it up yourself. You could do that, but it's much easier just to drop the variables on the pins and it automatically connects them and sets them a little bit back. So just for a little efficiency's sake there. All right, so we drag and drop those, the random scale max. And then the random float in range, the return value of that, let's set that into the new scale 3D input right there. Now, what do you notice about these right now? If I was gonna put this into there, this one's green, that one's yellow. What's going on there? If I try to connect those, look at that, it says convert the float to a vector. So green nodes are floats, which means they have decimals. The yellow ones are vectors. Vectors do not have decimals, they have to be whole numbers, okay? Which means they can't have a point something at the end of it, okay? So in order to do that, we're just gonna have a converter right here. So converts a double into a vector where each element is that float, whatever that means. The basic thing is it's converting decimal numbers into whole numbers and or vector numbers, and then putting those as our new scale 3D on there. So, all right, some nodes the conversion is done automatically. Some nodes, sometimes you'll have to put that converter in there. Yeah, Joe.
How do you add the converter in?
It does it automatically when you just connect it from here to here. It will automatically put the converter in there. So, but what I was just saying is that sometimes it does this. There are some nodes where it won't put the converter in there, and you'll have to put the converter in there.
What would it be called?
We'll get to that when we do it. So it'll be like a float to vector thing in there. It'll be a node that does that. So, all right, good. So anyway, so this is our construction script. So let's compile it. Let's do file, save all. And so this is our obstacle. So let me walk you through what we just did. So our obstacle is going to be an asteroid, but we want them all to be different. And we want them, as they fall down, we want them to rotate. So what we did, and we want them to do different rotation rates. So we created this construction script. It even says the place to spawn components and do other setups. So we're making each of the obstacles do a little bit different so they're not all the same and boring. We want a little variety there. So we did a set random rotation. We got a random rotator, which this is what makes the thing rotate. And so we plugged that into the rotation rate. And then we added a rotating movement component in there as the target, so meaning it's going to rotate. Well, what is the rate that we're going to rotate it? And I don't think we put that in there, did we? So anyway, the random rotating movement component is set over here. And so you can see the rotation rate. So when I clicked on rotating movement component, the rate is set over here at 180 degrees on the XYZ axis, okay? So it's gonna be rotating on the Z axis, and this is degrees per second. So it's rotating 180 degrees per second. So how long does it take to do a full 360 rotation? That's right, 2 seconds. 2 seconds, we're just doubling it up. 360 divided by 180 is 2 seconds. So that's what the rotation rate is going into there. But we also want it to scale so they don't all look the same. So we said scale the obstacle as small as 70% of the original size, but as large as 150% of the original size. And just do it randomly. Just randomly pick a a percentage between 70% and 150%, and then take that number and plug it into here, and that's the scale of the one that spawns next. So it's just gonna randomly set rotation rates and randomly set scale based on our parameters. So if you don't like your obstacle's speed, if you wanna speed it up, where would you go to speed it up? In here, where would you speed up the rotation rate? Think back to our windmill. Where did we set the rotation rate for our windmill? So our rotating movement component here, and then we do that over here in the details. So if I want to speed it up, I'm going to increase that 180 degrees and make it faster. I'll just increase the number. It's increasing the number of degrees per second that it rotates. Okay? So if you don't like it, if it's too fast, you make this number slower. If it's too slow, you make this number faster. All right. Yes.
Just a broad blueprints question. Could we have done this whole thing in the event graph as well?
So if you did it in the event graph, it would do this. No, it wouldn't work the same. It would apply it to all of them. It would do it. So what it would do is it would do this once, and it would set the rotation rate, and it would set the scale, and whatever random rotation rate it set and whatever scale number it chose, it would do that for each and every one that it spawned. By doing it in the construction script, it does it differently. It determines it goes through the calculations every single time it spawns an instance of the obstacle. Does that make sense?
Yes.
Everybody understand that? Okay. Remember at the beginning of this, I said you're not going to understand everything. So I'm trying to explain things as we go along. And later today, you might be walking down the sidewalk and all of a sudden you'll go, oh, now I remember what he's talking about. And sometimes that just happens. That happens to me all the time when I'm doing stuff like this. So anyway, all right, so that's that's setting up our obstacle. So I'm gonna save, file, save all. And let's see, it's let's see. Let's go ahead and take a quick break. It's 12:48, let's meet back in 10 minutes. And why can I not pause this? Yes.
You know how whenever you spawn, you know how the player was right under the camera?
Say that again?
So whenever you had that issue with the player control, like being too high.
Yes.
What I assume whenever you spawned it in, it was right under the camera.
Mhm.
So I assume this is what I just did, just to set it right there. Because I assume whenever you're doing,
So where did you set that?
so for the hero spaceship, on begin play I just did a set actor location.
Oh, you just did set actor.
Yeah, I just did it manually because I assume here, when you get the player controller, it's also setting it there.
Yeah.
That's what I assume. So I just set
Yeah, I may have missed that step. Even live demo, sometimes I missed it.
Yeah.
Because I look at you guys and I lose my place.
Yeah.
I may have skipped over that. Okay, great, thank you. So that was in Hero Spaceship, and then you just added the set actor location.
Yeah.
Okay, we'll go back and do that.
Okay.
Yeah, that's a great idea. All right, we able to recover? Oh, okay, good. Let's go ahead now. Got your rotating, you have a sphere, okay, click on add. And scroll down to where it says the collision rollout. Wait. Yeah, add a sphere collision. Okay, and just click here, right here, and then drop that on top of default scene root. Okay, good. And then set that to 50. And scroll down a little bit. And keep going. And yes, overlap all dynamic is correct. All right, click on the sphere. And then go down to where the collision is. Oh, it's back up. Okay, right here. Instead of block all dynamic, click there and say no collision. Because we don't want any collision on that one because we already have collision on that. So, all right, then go into your construction script and pull your rotating movement component down here. And drag off of here and type in set rotation rate. Do a set actor rotation rate, sorry. Actor, yeah. Nope, that is not it. Just delete that, and just right click, and do a set rotation rate. Set actors. Let me look at my book real quick. What does that look? Yeah. Let's see, drag off of this one. Now type in set rotation rate. There it is. Yes, there it is. Okay. Pull that up there. And then right click here and type in random rotator. Okay. And then connect them like we've got it there. Good. And then right click and type in set actor scale 3D. And then type in random float right click, random floating range. There you go. And then let's create a couple variables. So the variables, get the plus sign, and type in random scale in. And set that to a float. And then create another variable and call it random scale max. Very good. And then drag scale min and drop it on the edge. And just drop it right on it and drop that one on the max. Yeah. That one's up too. Okay. And then connect this into that. Converts it, and then connect that executable into there.
Is it just for randomization, basically?
Looks good. Compile and save. And then click on random scale min. Set that to 0.7. And then click on max. And set that to 1.5. Alright, compile and save. Alright, you got it through there. Good job. Yes, yeah, this is where I started. How many of you are just like completely lost? Everybody following along a little bit? Okay, good. All right, let's keep going on. It's one of those days I wish we could go till like 2 o'clock. We're not gonna get all the way through this, but we'll do what we can. So, all right, the next thing, hold on, let me get a drink. All right, the next thing is let's see if we just did this. All right, let's create the asteroid child class, the asteroid child class. So let's go into our blueprints folder. Yes.
It's still recording.
It's what?
It's still recording.
Yeah, I'm still recording. Yeah, for some reason this OBS doesn't have a pause on it. Mine at home has a pause, and I'm not sure why. Anyway, so I just let it run. So there's going to be 10 minutes of not doing this. I'll see if I can I don't know if I can cut it out or not. If I have time to take it into Premiere and cut it out or something. But
It's fine.
you may just have to
Yeah,
scroll through 10 minutes of of not doing this. So, all right. Where were we? All right. So we're back here in our blueprints folder, and this time, right-click. We're going to do another blueprint class, and and which one are we choosing? All right. So down here in the all classes. Type in the word obstacle, and when it comes up, choose it, obstacle, and then select. And then we're going to name this asteroid. Asteroid. All right, name it asteroid. And then double-click the asteroid blueprint class to open it up. Yes. It was an obstacle one. We right-clicked blueprint class, and then down here in the all classes we typed in the word obstacle. So it was in there somewhere. But anyway, we did that. Let's see. Okay, so we're in our, go into your asteroid blueprint. And then in our components panel over here on the left, I'm sorry, asteroid, yeah, in the asteroid panel, yeah,
What type of blueprint is the asteroid?
it's an obstacle blueprint. So if you go into all classes and type in the word obstacle, choose that.
Thanks.
And then double click the asteroid blueprint, open it up. And then here in our components panel, we're gonna select the static mesh component, which is sphere 1 currently. And that does not look like an asteroid to me, so we're gonna change it out. So before we do that, actually, because we did not, well, let's see. I know. We use starter content, so it's got the rock in it, so we're gonna use that. So select your sphere 1, and then over here in the details, click on that and go look for SM_rock. Stands for static mesh rock. We've used it a bunch of times before. There it is, SM rock, boom. All right, and use that. That's your SM rock, and I don't know why the material didn't come over. Let's make the material come over. Is there a rock material? Yeah, so you can choose the material and choose like that M rock material on it, so that works. Okay. So SM rock is the static mesh, M_rock is the element 0 material on there, so. All right, let's see. All right, so let's go to our location up here where it says 000. And let's change the location property to 00 -30. And set the scale to, you can uncheck or check the scale lock, so it's unlocked, and set it to 0.5, 0.5, 0.3. So 0.5, 0.5, 0.3. There we go. And notice now that it fits really nice and neat into our collision component size there. So, all right, that looks really good. And compile, file, save all. All right, I think Eric found where our hero spaceship, why it was not loading in the correct location. So let's go back into our hero spaceship tab. Let's go into our event graph, and then on event begin play, we're going to drag off of the executable and type in set actor location. Set actor location, and then we'll just choose it to be 000. And that's it. So compile, file, save all, and let's do a quick little test. Yeah, Ethan. I'm in the hero spaceship blueprint. I'm keeping all my blueprints open up top here, so I don't have to keep going back and finding them. So in hero spaceship, I added to the event begin play a set actor location, and the location is just going to be the center of the game, 000. So, and then compile it. And then I'm going to go back into the level and I'm going to hit play and see if that, yeah, see now I can see my spaceship. So that looks really good. All right, let's move on. Thanks, Derek. Good job figuring that out. And stop it. And all right, the next thing is we want to damage the pawn. How do we damage the pawn? Hunter, you have a question? Say that again? Say the last word again. Oh, the movement? Yeah, I figured it out, but I haven't, for some reason it's not working, so I'll have to. What's that? Yeah, I'll have to make a video and send that to y'all tomorrow or the next day, so, because it's not, I worked on it last night and I couldn't get it working, so I figured let's get as far as we can with the stuff we do know. It's just one thing that's not working. Everything else is working great, so I'll figure out the one thing, send you a video, unless someone in here figures it out, but anyway, let's keep going. We're gonna damage the pawn. So let's open up our hero spaceship, if you're not there already. And in the My Blueprint panel, over here on the left-hand side, the My Blueprint tab over there, let's create a new Boolean variable and name it isDamaged. So you can click on, instead of going into variables, you can do that, but let's do it a different way this time. If you click on the add, see I can click on variable there, and then let's name it isDamaged. And this is a Boolean, so it's either yes, it's damaged, or no, it isn't. So we're gonna leave it as a Boolean, yes or no. And we could just as easily have clicked on the plus sign right there to create this variable. So it's just a nice, easy way to have it up there as well. All right, so let's click on compile, and then we wanna start isDamaged as false. So over here, the value is unchecked. That means, is it damaged? No, it doesn't start off being damaged, so isDamaged is false, because it's not damaged. So we leave it unchecked. Then in our components panel over here, let's create a particle system to show when your spaceship is damaged. So let's click on the add button, and then we're not going to use Niagara particles because I don't have a Niagara particle for this. I do have an old what do you call it, Cascade particle system. So let's scroll down until we find the Cascade particle system. Wherever that, I guess I could have just typed in the word Cascade, but there it is. Under rendering, Cascade particle system component. Unless, I don't see one that just says particle, did I miss it maybe? I guess they're differentiating between the two. So yeah, use the one that says Cascade particle system. Cascade particle system component. And let's name it damage particle system. Damage particle system. All right, and with damage particle system selected, over here in the details, we've got to find the particle right here. See where it says template? There's currently no particle system in there, so let's click that and let's add the P-Fire. The P-Fire. Right there. So I told you when the pawn, our spaceship, gets damaged when it collides with an asteroid, it's going to catch on fire for the first hit. That's what we're doing right now. So, all right, so it catches fire, but we don't want it to be on fire from the beginning. So let's scroll down and set the damage particle system's auto activate to false, which is probably near the bottom. They usually auto activate, keep scrolling to the bottom, there it is. Auto activate, uncheck that. We don't want it to be on fire from the moment the game starts. We want it to be on fire when we have the collision. So uncheck it. And then in the My Blueprint panel over here again, let's click the Add New button, and this time have another variable, or no, we're going to do a function this time. Sorry, not a variable. We'll do a function and call it Take Damage. A Take Damage function. All right, and so you should be in the Take Damage tab right there, and what we'll do is drag off of the executable node here and type in the word branch. And we're going to put a branch node in there. And then drag the isDamaged variable onto the condition right there. So over here we made our isDamaged Boolean variable. Click, drag, and drop that onto condition. So it's checking to see, the branch is checking to see, is our hero spaceship damaged? So that's what this branch does, is it checks to see if it is damaged. it's either true, it is damaged, or false, no, it's not damaged, okay, is what we're doing here. So we're gonna click off the false pin and place a set is damaged node. Set is damaged. So if the condition of is damaged is false, meaning it's not damaged, then hold on, I set is damaged node, set the is damaged node to true, click, check it, is damaged is true. So when it takes damage, if it's currently not damaged, then it's going to set it to damaged, is what we're doing here, okay? Everybody got that? So it's not damaged, but it takes damage. All right, if you don't have any, if you're currently not damaged, but you took damage, then now you have to be damaged, is what it's doing. Does that make sense? All right, and then we're gonna drag the damage particle system and place it to the right of the set is damaged node. So over here in our components, drag your damage particle system, click drag and drop it just to the right of it and maybe underneath it. I think it does it automatically in the next step, but you can also just do it here by itself. And then let's drag off of the damage particle system, the blue reference node there, and type in activate. Activate. And we're going to activate the damage particle system there, and then hook these two together. So hook the executable from the set is damaged to the activate, and then everything else is good. Then we're going to compile and save. Compile, file, save all. All right, good. So once again, for all the designer artists, I know you programmers get this. So when an asteroid collides with our ship and it's currently not damaged, it's not flaming it on fire, the branch checks to say, hey, are you damaged? And if you're not damaged, but you just took damage, then it's gonna set it to, if you're not damaged, it's gonna set it to, yes, now you have damage. Which means we're gonna activate the damage particle system, which is the fire that we set up over here in our damage particle system, okay? Later we'll go back and we'll set something to the, hey, you were damaged, now we've gotta destroy you. Because you get one opportunity, and if you were damaged, then we're gonna do something to you. You're gonna leave the game. So anyway, so that's where we are now. All right, now, how do we handle overlaps? So the asteroid actors need to call the take damage function whenever they overlap with the pawn, and they also need to be able to destroy themselves. So now we'll take steps and to do that. So let's go into our asteroid blueprint, and make sure you're in the event graph of our asteroid blueprint, and there's some parent events in there as well. Yeah.
What was the scale for the asteroid again?
Min was 0.7, max is 1.5. And so, you mean the, yeah, so 0.7 and 1.5. All right, so we're in the event graph from here, and we're gonna click drag from the event actor begin overlap, not the parent one there, but we're gonna do it from this event actor there. So drag off the executable and place a cast to hero spaceship. Cast to hero spaceship node in there. Cast to hero spaceship node. I'm gonna disconnect this parent node, holding Alt and clicking on the connections right there, and that can go wherever. All right. In fact, let me drag these two out so we're not. There we go, so you can see them a little better. All right, let's see. And, all right, so good. The executables are hooked up together. And, all right, and then what we'll do here is dragging off of the, drag from the cast to hero spaceship nodes as hero spaceship. So dragging off this blue output pin right there and type in take damage. Take damage. Oh, what happened? No, I hit something wrong, that's not right. Drag off, take I clicked on the wrong one there, take damage, there it is, that looks right. Alright, so remember we're in the asteroid, so when the asteroid and our pawn overlap, then we're gonna take some damage on the hero spaceship, because we're casting to the hero spaceship using this node. So when the asteroid and the pawn overlap, we're casting there and the spaceship is going to take some damage. All right, let's see. Then we will, off this take damage executable, type in spawn emitter at location. Spawn emitter at location. Very good. All right, and then next, for the emitter template there, part of the starter content is there is an explosion. So let's type in, click there and just choose P explosion as our emitter template that we're using. And then underneath this spawn emitter at location, right click and type in get actor location. Get actor location. All right, and where do you suppose that's gonna go?
Location.
There you go. Instead of typing in a location there, it would be impossible. We don't want the emitter to spawn at the same XYZ coordinates every time it happens, because what's my pawn, my spaceship is going back and forth all the time. So one time it gets hit, it could be over here. I want the explosion to happen here, but another time it gets hit, it could be over here. So if I were to set a specific X, Y, and Z location, it would always be, the explosion would always be happening at the same XYZ coordinate. I don't want that. So that's why we add the get actor location. It's gonna get the location of the asteroid. It gets the location of the asteroid when it collides with the spaceship, and that's where the explosion is going to happen. So it always happens at the location where the collision is, not at some preset XYZ coordinate. Yes, Joe?
Is the get actor location basically like a game object's transform in Unity? Is it the game actor location basically like a game object's transform?
Yes. Yeah, it's grabbing those XYZ coordinates of the location transform. Yep, very good. And there's also get actor rotation and get actor scale. There's those nodes as well. We don't really need them in this particular instance. We just need the location. So, yep, very good. Let me see where I was. We hooked it into the spawn emitter. Okay, and then once we have the explosion, it's been hit twice. What do we want to do to the spaceship? What's that?
Destroy the
Destroy it. So let's drag off of the spawn emitter at location and type in destroy actor. Destroy actor. Boom. All right, let's see. And then let's compile and save. Compile, oh, what did I do? Oh yeah, look at this. So the other actor, I did not drag that onto the object of the cast to hero spaceship, did I? So, because I don't want the asteroid, I don't want it to happen to the asteroid, I want it to happen to the spaceship. So the other actor is the spaceship object right there. So we had to connect those two. Now when I compile it, it should work, which it does. All right, very good. Let's see, let's Let's do it. Compile, save all. I don't know, let's go back into your level, let's hit play. Oh, we didn't put any in there yet. So stop it. Put some asteroids in your level, which put some asteroids in your level. So just drag them in, obstacles, I'm sorry, not asteroids, put obstacles in there. Drag some obstacles, and I'm gonna set them, actually just drag one in there, and then make sure the Z location is at 0. And then you can, let's see, I'm gonna pull it back. And then I'm going to Alt drag just some of them down there, and then hit play. Oh, they're rotating, they're not moving, what did I do? And what does my asteroid look like that? Let's see. Obstacle, rotation scale, yes.
Do we use the asteroid one or the obstacle?
Let's see, I think we use the,
Because the one that we changed the appearance is the asteroid and not the obstacle.
oh yeah, put the asteroids in there, not the obstacle. Thank you, sorry about that. So, I'm gonna delete my 4 obstacles, drag some asteroids in there, make sure the Z is set at 0, and then put multiple ones in there. I don't know if we put them in the top, do they flow this way or do they flow that way? I don't know, we'll figure it out. But, all right, the size is working. I'm gonna hit play. All right, they're spinning, yeah.
Can you explain the logic behind the obstacle and the asteroid movements? Like, why do you need, or can you just explain what's going on there?
Yeah, so if you'll notice, look at all the obstacles here. They're rotating at different rates, and they're also different sizes. And so we don't all want them to look the same, because in our video game, that would be boring if we had them all the same size and they all rotated at the same rate. So we're just adding a little variety, and then we did that up here in our obstacle class. So this construction script is where we set the random scale to make them different sizes, and then this rotating movement component is where we set up the random rotation amount. Is that what you're asking?
Yes.
Okay. So this is where we set that up so that it just adds variety. And the other thing is, the reason we did that here is because when the asteroid is spawned, because eventually we're not going to drag and drop them in there, we're going to set up spawn points and they're going to spawn in procedurally. But when they spawn in, we don't want them all to be the same every time they do that. We just want them to look different and rotate differently. So by setting up the construction script, and this way we only had to do one blueprint for the asteroid, and so, or for the obstacle, because the construction script allows us to add variety even though we have one blueprint class to it, okay? Otherwise, if we didn't have this, we'd have to make, if we wanted 6 different types of asteroids, we'd have to make 6 different blueprint classes. The construction script allows us to make the changes for every instance that is spawned of one blueprint class.
So we made the asteroids, so the asteroids are children of the obstacles, right?
Yes.
So I'm just curious, but since you have the event graph, an obstacle, is it possible that could the construction script apply to that in the event graph somehow? Where maybe you wouldn't have.
I don't think it would work the same. Yeah. Joe, did you have a question?
Yeah, I was gonna ask how are we gonna how's the asteroid and the obstacle, how are we gonna interconnect those?
I'm sorry, I didn't hear you. Can you say it a
Like,
little
how are
louder?
we going to, maybe it's already been done, but like, the asteroid and the obstacle, how are they gonna be connected?
Yeah, we haven't set that up yet. Yeah, we have not set that up yet. All right, we've only got like 4 minutes. I'm gonna see if I can get through one more thing before we call it a day. So, all right, so we're gonna create a death state for our spaceship. So go into the hero spaceship, and we are not gonna finish this today. I apologize. So I'm gonna make it homework for y'all. And so I'll get the pages scanned, and I'll get those to you all. If I don't do it today, I'll do it tomorrow by noon for sure. So, all right. So anyway, open up your hero spaceship, and in our My Blueprint panel over here, we're going to add a new function, and we're going to call it On Death. On Death. And then we're gonna double click this on death. Where'd he go? There it is. On death. We're gonna double click it. It opens up the construction script for it. And let's see. We're gonna drag off of the on death executable pin and type in spawn emitter at location. Spawn emitter at location. And that will place a get actor location. So right click and type in get actor location under there. And hook it up, hook the return value into the location of the spawn emitter at location. And let's see, drag from the spawn emitter at locations executable and type set actor hidden in game. Set actor hidden in game. And then set the input pin new hidden, set it to true. So let's check it. And then drag off of the set actor hidden in games executable pin and type in set actor enable collision. Set actor enable collision. And then drag off of that executable pin, place a set timer by function name. Set timer by function name. And then we will place a get game mode. So right click, type in get game mode right there. And then hook the get game mode return value into the set timer by function name object input pin. So the blue to the blue right there. Set the timer by function names, function name input. Right there where there's a little box, click there and type in the word restart game. It's all one word, capital R, capital G, restart game. So when you type things in these little boxes right there, it's important to type it exactly, to be precise. And then set the timer by function names time input to 3 seconds. And then over here, our take damage function, double click our take damage function, and then click drag from our branches true. Remember I said we'd go back and revisit this to put something in true? So drag off the true and then type in on death. And the function that we just created will be the death right there. It'll play the death sequence, which is the explosion and all of that stuff. Let's see, on death, let's compile, let's do file, save all, and go back, hit play, and I don't know why I forgot a step because otherwise these things should be moving. And I don't know why they're not moving, so I'll have to go back to figure that out. But anyway, we did good. Everything looks really good right now. There's just a couple things we gotta go back on. And any questions, look me up on Teams. And let me stop the video.